guys, this video is about the Bernoulli's equation. So first, I want to introduce to you the two cases that is derived from the general form. For case 1, the dy over dx, this is the general form, the integrating factor, and the solution. For case 2, the dx over dy, this is the general form, integrating factor, and the solution. So for us to understand better, we have here a sample problem. So the first step is to distribute the first term. So we have here, we copy 6, y squared plus y is equals to y cubed minus xy minus y, and then copy dx plus 2x dy is equals to 0. Next is we will find the general form. So as you can see, we have no general form. So in order to do that, we will divide the whole equation to 2x dx. I separated the whole equation into two terms because it is easier to understand. Now we can obviously see what to cancel. So we cancel dx and 2x since it is similar. And now we have found our general form, the dy over dx. With this general form, we will use this as our leading term, so we will rewrite the whole equation. We now have dy over dx and then separate this equation. So we have plus 6y cubed over 2x minus xy over 2x minus y over 2x equals to 0. We will now simplify this term. We will copy dy over dx, so 6 divided by 2 is equals to 3, copy y cubed, and then over x, and then we can cancel x, so we have y over 2, and then copy the negative y to x. Our dependent variable will be y to the power of 1, so all the y variables with the power of 1 will be on the left side of the equal sign, and the y variable with the exponents that is more than 1 will be on the right side of the equal sign. So with our equation, I checked the y variables with the exponent of 1 that will be on the left side of the equal sign. Now we will rewrite the whole equation. So dy over dx plus the variables, y variables with exponent of 1 will be on the left, and then 3y cubed over x will be on the right side of the equal sign. Now we will extract the y variable both sides of the equation. So we have dy over dx plus y since we extracted y, and now we are left with negative 1 over 2 and negative 1 over 2x. And of course, on the right side, we will still extract the y variable. So our y variable will be y to the power of 3, and we will be left with negative 3 over x. And with this, we can now have our p, our q, and our n, which is the exponent. After deriving the p, q, and n, we can now solve the integrating factor where we use the case 1. First step is we will substitute the equation. So we have here e to the power of integral 1 minus n, which is our 3, and then the p, which is the negative 1 over 2, and the negative 1 over 2x dx. We will simplify this equation. So we have e to the power of integral negative 2, and then copy the negative 1 over 2 and the negative 1 over 2x dx. So as you can see in this equation, we can distribute the negative 2. So we copy the e and then the integral. So we can cancel the 2 and the negative. So we will be left with 1. Cancel the 2 and the negative again. So we will be left with plus y over x dx. So now we can separate the equation. We will rewrite the equation as e to the power of integral 1 dx plus e to the power of integral 1 over x dx. So of course, we all know that the integral of 1 dx will be x, and the integral of 1 over x dx will be ln x. We can rewrite this equation as e to the power of x times e to the power of ln x, where we can cancel, and we will be left with e to the power of x times x, or x e to the power of x, which will be our integrating factor. So since we have our integrating factor, we can now solve the solution, which we use the case 1. So first, we will substitute the equation. So we have y to the power of 1 minus 3, our n, then x e to the power of x, our if, is equals to the integral of x e to the power of x times 1 minus 3 times negative 3 over x dx. Now we will simplify the equation. So we have y to the power of negative 2, copy, is equals to the integral of if, copy, and then negative 2 times negative 3 over x dx. We can arrange this equation. So now we have x y to the power of negative 2 e to the power of x is equals to, we can multiply this. So we have 2x e to the power of x times negative 3 over x dx. So now we can copy the equation, and we can see that we can cancel x and multiply 2 and 3. So now we have 6e to the power of x dx, and we all know that 6 is a constant number, so we will rewrite the equation and we will put 6 outside the integral. So now we have integral of e to the power of x dx. We all know that the integral of e to the power of x will be e to the power of x itself. So we now have 6ex plus c. We notice that we have a negative exponent which is not allowed, so we can cancel it by x e to the power of x over y to the power of 2 is equals to x e to the power of x plus c. So this can be our answer, but some prefer it to be simplified. To simplify the equation, we will divide the whole equation into y to the power of 2. So we can cancel now the denominator, so we will have x e to the power of x is equals to, we will multiply, so 6 y to the power of 2 e to the power of x multiply, so c y to the power of 2, and this will be our final answer.